And thank you to all the people who put on React Europe. It's great to be here. It's a really well done conference. Thank you all for being here. Thanks to the AV people and the people who clean and feed us and everything. My name's Sasha. As he said, I used to be the CTO of Redfin. I wrote a library called React DOM Stream. I also, weirdly, for React Europe, am the second native Arizonan up on stage, which is really strange. It's a small state. But I want to talk to you about streaming React today. And I always like to start talks off talking about what problem I'm trying to solve. And this is the problem I want to solve. It drives me nuts. Performance on the first load of React pages. And I have to say, I'm really excited to hear so many people in this talk today, Andrew, Dom, Sunil, talk about performance. I think it's really important for the React community. And if you follow web performance Twitter, you may know that React doesn't have the best reputation sometimes in the performance world. And frankly, I think that's kind of right. But I think it doesn't have to be that way, and we can fix that. So I want to try and convince you that this is a real problem. First, I just want to quickly mention why I care about performance. And that's because performance really does directly impact your bottom line. There are tons of studies on this. Just to share one that was recent, just last quarter. Soasta, a company that runs tons of different e-commerce sites, did a study on conversion rates. And they found that when pages got slower by just 100 milliseconds, conversion rates went down by over 2% on desktop and 7% on phone. And if they got slower by 1 second, you lost a fifth of your users. 1 out of 5 people just walked away for 1 second, even on desktop and on mobile. So that's what I want you to have in the background while I talk about the rest of this. So I said I'm going to talk about React performance on first load. And it's not to say that second load of a page isn't important, but there are a lot of tricks you can do with that. There's HTTP caches, there's service workers. If you don't know about those, find out about them. They're great. But I want to talk about first load, partially because a lot of us don't run sites like Facebook or Twitter where people are coming back every day. And so we often don't even get to second load, especially if first load is slow. So I always like using a sort of example. So I decided to make a demo example for this. And I'm going to introduce it right here. It's my new website, the React Europe Daily. Looks like this. It's a site for us to publish articles and gossip about React Europe. Really, it's just a dummy page. But it's a little React app I built. I used Create React App to sort of start with the defaults. Semantic UI React for controls. And it's really stripped down, but it has 3 API endpoints. It's got one for a headline, one for article text, and one for comments. And each of those have sort of a synthetic amount of time they wait to simulate looking for a real data from a real database. And so I wanted to make this site so I could show you how it loads in different ways. Now, since I made this with Create React App, it starts out with the default in the React world, which is client rendering. And what does client rendering look like from a 10,000-foot view? Well, this is what most React sites, I think, these days use. And let's look at the architecture from a 10,000-foot view. There are 3 basic actors here: the browser, the web server, and an API server. I'm talking about pages that use APIs and want to display data. And the basic flow looks like this. Browser asks the web server, hey, I want this page. Web server returns an HTML page. It's usually really, really small. Just use like one DOM element to hook onto, and then some links for CSS and JavaScript. This makes the browser turn around and say to the web server, hey, I need that CSS and JavaScript you told me about. So the web server returns those. Then the browser has to parse and execute the JavaScript. And a couple people have mentioned this already, but parsing JavaScript is often an overlooked expense. It can be a lot more expensive than you think if you haven't measured it directly. Now, the worst part is, at this point, it still doesn't have the data it needs to display. So it runs the JavaScript and sees, oh, I got to go talk to this API server, asks the API server, hey, give me your data. API server churns on that for a while, returns it some JSON. And only then is the data and the code all together in the browser, and we can call React DOM.render, which actually is not the end. That just generates a DOM tree for the browser. And then the browser has to go ahead and lay out and paint, which is also often a pretty expensive operation. So what does this look like? Well, let's pull up React Europe Daily, and this is a video taken from Web Page Test, and I'm testing this on Chrome desktop browser over DSL. And let's see what happens. All right. Go, 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 run, 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 run. All right, that was over 4 seconds to load, which I don't know how you all feel, but that really makes me mad when a site takes that long. And as you saw, 1 second, just 1 second, you're losing a fifth of your users. But if you don't think that's bad, let me show you what it looks like on a Moto G4, which is sort of a middle-of-the-road phone, on emerging markets 3G. I think it was really important. Earlier today, Sunil was talking about how networks in emerging markets can be very different. And let's go ahead and see that same site running on a real device on a simulated emerging 3G network. Anyone know some jokes? Seriously, we got time. Angular, that's a good joke. I like it. All right, all right. No, I'm sorry. That wasn't mine. I don't believe in talking bad about other people. Everything is great. Angular has its wonderful things. I want to take that back. Okay. So that was a long time. That was 13 seconds to paint and 13 seconds to interactive. That's terrible. That's terrible. So what can we do to fix that? Well, the first thing that, why is that terrible? Well, I claim that the biggest reason it's terrible is that things are being used in serial. They're not being done in parallel. On these sorts of apps, there are generally 4 resources we're optimizing for or we're using. The browser CPU, the network between the browser and the servers, the web server, and the API server. And rendering something like this the waterfall looks something like this. And I'm not going to go through each bar and what it means, but I just want you to notice that none of the bars overlap horizontally. Everything is being done one thing after the other. So it makes it really slow. So the usual first thing that people do is server rendering, which is great. I love server rendering. It's one of the things that brought me to React, frankly. And server rendering, I'm sure a lot of folks know, you load data on the server side. So rather than the client talking to the API server, you have your web server talk to the API server. And once you get the data on the web server, you call react.server, render to string, create the HTML markup, and send it down to the browser. After you do that, you also have to send the JSON data down to the browser from the web server. And only once you have both the data and the markup, and the JavaScript of your components on the browser, can the browser call render and make the markup interactive. Let's do the 10,000-foot view of that, so for folks who want a sort of visual of it. Browser asks the web server for a page. The web server returns just the head of the HTML this time. It doesn't return an entire HTML document. And at the same time, it makes a request to the API server. The API server is churning in the background. And the browser is smart enough to be able to look at the head of the HTML document and say, oh, I'm going to need some CSS and JavaScript, so get those in the meantime before I have anything else. So it gets the CSS and JavaScript. And maybe already the API server has now finished its work and is returning the data to the web server. Now in this frame, I'm showing that the browser can now start working on parsing the JavaScript while the web server is generating the pre-rendered markup. Then the pre-rendered markup gets sent down to the browser. And the browser can work on laying out the pre-rendered markup, doing the layout and paint phases, while the network is busy getting all the data from the web server. So we have a little bit more parallelism here. And then once the data comes down, the markup is actually interactive after we call render. So if you look at a waterfall, it's a little bit better. The API call is earlier. There's a little bit more parallelism between the network and the browser later on. And let's see what that looks like for my little toy site. Now I should tell you, I coded a feature in React in this toy site where the first render of all the components puts a red box around them. And then on the first animation frame after they've been rendered, it removes it. So that is obviously not something I would put in production, but it's just to give you the ability to see which parts of the application have become actually interactive with React versus when they're just pre-rendered markup. All right, so Chrome desktop over DSL. Remember the time to beat is 4.1 seconds for client rendering. And why is it not? Oh, well, let me Why is this not? No, that's not going. There we go. There we go. All right, so we start it, and see, did you notice we got a paint there of the content that came down from the server? I'm going to go through it slowly. We started with a blank page, with a blank screen at 0 seconds. Now, at 1.7 seconds, we had the entire page rendered on screen. You know, we've saved over 2 seconds for first paint from client rendering. That's phenomenal. And then time to interactive is 3.2 seconds. So even though we're doing more work with server rendering, we're getting to interactive a lot faster, almost a full second faster. And now let's check it out on the Moto G4. Reminder, the time to beat is 13 seconds. It's not quite as nice. We're on emerging markets 3G, but we got something within the first 3 or 4 seconds. And there we go. So I'll walk you through that. What that looked like was a blank screen at 0 seconds, and then at 3.3, we got a full paint, and fully interactive page by 9.6 seconds. So we've saved 3.5 seconds on the full render and almost 10 seconds on first paint. That's phenomenal. So obviously the great things about server rendering are that it's a lot faster to get content up on screen, right? The downsides, there's some downsides though. As much as I'm a fan of server rendering, I have to admit there are some downsides. One is that you do need a dynamic web server. Right? The good thing and the most awesome thing about client rendering is you can just put a bunch of static files up on a website, on kind of any site, and it'll just work. There's another weird thing, which is that it's getting faster, but we're actually sending more content down, because we're sending the JavaScript, the JSON, and the CSS, but we're also, in addition, sending that pre-rendered HTML, which we didn't send down in the client case. So it's technically possible that it can take longer for server rendering. In practice, my experience is that this almost never happens, because it really only happens in situations where you have really high CPU on the client that can parse and run JavaScript super fast, and a really slow network. And generally, if you have a really slow, degraded network, you're dealing with phones that don't have particularly good CPUs, so this is not usually a combination you see in the wild. But the thing that I think is sort of the worst about server rendering is that long period of time where you had the red boxes around the content. The long sort of uncanny valley where the content is rendered and painted on screen, but it's not interactive. This can be terrible for users, right? Like, you have buttons that don't work, forms that you try and click and they're not interactive. Somebody earlier was mentioning this. It's this weird, sort of half state where the page is not really acting the way it should. Paul Lewis from Google is the first one I saw who called this particular state Uncanny Valley. And what's even worse is the longer the page gets and the more you add to the page, the longer that Uncanny Valley takes. And this is why I like to say that at some level, server rendering doesn't scale. And by that, I don't mean, on a server, it takes up too much CPU. What I mean is it doesn't scale with more features. So imagine somebody came to me and said, hey, I love your site, ReactEurope Daily, it's great. But wouldn't it be great if below the comments section you added a thing where it said related articles? And I'd say, oh yeah, I've seen other sites do that, I should do that. And I'd get to coding it. Well, this is a problem, because a new feature is going to add more CSS, it's going to add more JavaScript, and it's going to add more for the server renderer to do. And so, because it adds more JavaScript, the time to interactive, even of the stuff above the fold, takes longer, right? The time to first paint of the stuff above the fold also takes longer, partly because rendering more content on the server delays the time to first byte of content, and partly because rendering is always blocked on CSS, and the more CSS you add to your head, the longer you get till you get first paint. And this puts us in a really tough place, and I've seen teams be in this place where there's this constant seesaw between features and performance. And somebody says, hey, we want this new feature, our customers want it, it's gonna be great, and somebody else, who usually gets overridden, frankly, says, no, we can't do it, it's gonna slow down the page. And I want them to be friends. I wanna be able to add more features and not slow things down. So, HTML streaming to the rescue. So, what is HTML streaming? Well, there's this feature that's been in browsers for as long as browsers have been around, which lets browsers deal with the fact that HTML is coming off the network in little bits and dribs and drabs. And browsers have become extremely good over the years at rendering just a part of a page as it comes in. So first component comes in, it renders it, second part of the page comes in, third part of the page comes in. So the render to string method is a synchronous single method on the server. But what if we broke the page up into parts and sent it down? Then we could use HTML streaming and send parts of the page, and it would render in pieces. And that sounds like a really good solution. Unfortunately, sending just the HTML isn't going to be enough, because HTML has friends, CSS, JavaScript, JSON. And it gets kind of complicated when you try and figure out how to send all those pieces of information down to the browser in the right way. This is just part of a chart I was sort of drawing to help me think about it. But the thing that I want you to take from this is that you need CSS and HTML to get to first paint, and you need all four of them, the CSS, the HTML, the JavaScript of your components, and the JSON data to get to interactive. And when you start to look at this and think about this, I claim that you end up deciding that this is the right order to send stuff down, right? And not just for the whole page, but for each chunk of your page so that the browser can work on each chunk. And I encourage you to think of these things as all one component. Think of this, break down your page into components and send these down one by one. I'm going to call this server chunk rendering. Uses streaming, you could call it streaming if you want. But what would that look like for the React Europe daily site? Well, first thing is we would need to break it down into what I'll call root elements, pieces of the DOM tree that are sort of at the root that can be rendered separately. And let's say the first one is this header, which actually has no data at all. It can be rendered before the API server even returns. And I would want to split out the CSS and the pre-rendered HTML and the JavaScript that needs to be sent down for it, and the data, if any, that needs to be sent down for it. Then we'd have the article next, and we'd separate out the CSS, HTML, JavaScript, and JSON for that, and then the comments section. And we'd send them down in this order. So we'd send down all of the pieces of the component. I mean, we'd attempt to send them down in this order. All the pieces of the first component. And once the browser gets all those, it can both paint and make interactive the header. Once it gets the next four, those orange ones, it can paint and make interactive the article. And then finally, when it gets the last bits, the green, the ones I put in green, it can paint and make interactive the comments section. Now, I said we'd attempt to send them down in that order. Turns out that this is a really hard problem to stream things really carefully in the right order to the browser. There's about 5 million different ways to load each of those kinds of resources. I've put some of them up on the board. It's actually a really hard problem, and people should be working on this problem. It's really fun. The good thing is that even a naive version of it does pretty well. So what does this look like from our 10,000-foot view when we're doing chunked rendering? Well, the browser asks the web server, again, hey, give me an HTML file. It returns the head of the HTML file so the browser can start. And just like in server rendering, it makes a request to the API server. API server works for a while. And then the API server returns maybe just the JSON needed for the first section of the page. This lets the web server start calling render to string on the first section of the web page, while at the same time, the API server could be returning the data for the second section. Once the web server has finished rendering that first section, now we send down the CSS, the HTML, the JavaScript, and the JSON data all together for that first part of the page down over the network, while at the same time, the server's rendering the second, and at the same time, the API server is returning the data for the third section. Go forward one frame, and the first section has arrived at the browser. The browser can start laying out and painting that information, while the second root element is being sent over the network, while at the same time the third one is being rendered on the web server. They just keep stepping forward. Then on the browser, the first part of the page is made interactive, second part is being laid out, third part is being sent down the network, and so on and so forth. This is what a waterfall of that would look like. There's a lot more parallelism. You can actually get content in the browser before some of the API endpoints have even returned, maybe even before any of the API endpoints have returned. Let's look at some code. I'm going to show just a sort of simplified version of the code I did for the demo, just for one component, just for the article, to try and emphasize how I'm sending down each of these things in serial. So this is from an Express route. First thing I'm doing is writing out the CSS. I decided to inline it. There are good reasons and bad reasons for that. Talk to me offline if you're interested. And notice that this is a separate CSS bundle just for that one section of the page. It's really critical that we do intra-page code splitting for both CSS and JavaScript to make this work. It's like the code splitting we do in Webpack for different routes, but it's actually for different root elements in one page. Then I call response.flush. This makes sure that the content makes its way down to the browser and that the browser can start working on the CSS while the server is working on what it's working on. Then we say, hey, we need to wait for the API endpoints to come back. Once they do, asynchronously, we then call render to string of just the article part. And once again, we flush that down to the browser. Now the browser has the CSS and the HTML. It can start painting and laying out non-interactive content. Then we go ahead and tell the browser, hey, you also need to get these JavaScript, this JavaScript for these React components. We flush that down to the browser. And finally, we serialize out the data and embed a call to react.dom.render for the client and flush that out. And that's the JSON data. And so that's each of the 4 components we wanted to send down for the article: the CSS, the pre-rendered HTML, the JavaScript components, and the JSON. So let's look at what that looks like with this. All right. Whoops. Where? Oh, I lost it. It's not loading. Well, I'm going to show you what it looked like. For some reason, my video isn't loading. So the time to beat for Chrome DSL was 1.7 seconds on Paint and 3.2 on Interactive. What happens, you'll have to trust me on this one, is we start with a blank page, and then in 1.2 seconds, we get the header showing up. And notice it doesn't have a red around it. It's actually fully interactive at this point. Note we've got it fully interactive before the previous version could even paint at all on the screen. Then the article shows up at 1.5 seconds. Still fully interactive before the previous version, the server rendered version, was able to paint it all. The comments take a little longer because they're large, obviously, and we've used more network for JavaScript earlier on, so they actually take a little bit longer than it took to paint in the previous version, but they get interactive a lot faster too. Let's see if I have the video here. I might have just lost my network connection. Oh, no. No, yeah, it's not working at all. OK. All right, so the Moto G4 version, the time to beat was 3.3 seconds on Paint and 9.6 on Interactive. It starts with a blank screen. The header shows up, non-interactive, then the article. So in 2.7 seconds, we've now got all the content that somebody wanted to see in the streaming version, because we're not waiting to render all the comments on the server. It's still a pretty low-powered device on a really, really rough network, so it still takes a while to get to interactive, but it's much better than the 13 seconds. We've had some response for the user in 2.5 seconds, and most of what they want within 2.7 in terms of painting. So what are the pros of chunk rendering? Well, as I showed, it's usually the fastest time to first paint and fastest time to interactive. The thing that makes me most excited is as the page scales up, as you add features further down the page, the time it takes to render the top of the page stays constant. This, in big teams especially, is, to my mind, really liberating, because you don't have to have that endless conversation between, oh, we need to add a feature, no, it's going to be too slow. There's another cool side effect that I didn't really think about till I started using this, but it makes the pages a lot more fault tolerant of API endpoints that start freaking out. Imagine that comments API endpoint started taking 10 seconds, just super long, right? In the client rendering version, we would have to wait 10 seconds before we saw anything, before we saw the header, before we saw the article, before we saw anything. In the server rendering case, we would also have to wait 10 seconds until we saw the header, the article. In the chunked version, we're going to get that header and that article just as fast as we would if the comments API endpoint wasn't misbehaving. It'll still take a long time to the comments, but we're going to be able to get something to the user, even in a failure case. What are the downsides of chunked rendering? Well, I alluded to this. Intra-page code splitting is really hard. Webpack, it took me a long time to get it all working. I had to hand tune a lot of things. I love Webpack. It's not quite designed to do this just right. Specifically, it doesn't chunk CSS into files for separate chunks on a page. There's a lot of stuff that needs to be figured out. It's also, as I said, it's tricky to implement the sending down of all the resources in the exact right order. And I think there's a lot of interesting research to be done there with server push, with HTML imports, with all sorts of other pieces. So there are 4 lessons I'd like you to take from this talk, if you remember nothing else. The first lesson. My first lesson really is that there really is a problem with performance in a lot of React sites. Not all React sites, but a lot. And it doesn't have to be as bad as client rendering. You can be a lot faster than client rendering. And in case you think that I was tipping the scales a bit because the demos I showed were on DSL, which is relatively slow broadband, or very slow broadband, and emerging markets 3G, I just want to show you some numbers from running that same test on a Chrome desktop browser on a fiber connection. Now, I ran that same test, and look at this. The first paint on fiber, you get 2.3 seconds faster, and you shave off a second on desktop on fiber. And remember, that second is like 20% of your users, 1 out of 5 of your users. Making things faster, and doing better than client rendering is something that I guarantee you will pay off. Lesson 2. When you move to a world where you start streaming things down to the browser, it enables you to not have that argument between features and performance. It enables the part above the fold to stay constant, and that is a great world to be in. Lesson 3 is that as we move to a world where more and more sites are built this way, designers and developers both have to be conscious of it in 2 main ways. One is, I really think we need to be thinking about our pages as separately renderable pieces. So you really need to break it down and think, what parts of the page am I okay with being rendered separately from other parts? Obviously, there are some pages that are sort of super app-like that may not work very well in this. But I think most pages can be broken down into separately renderable things. The other thing that I think you need to design for and develop for is really designing for that uncanny valley. So making it so that the server rendered version, the very first rendered version, all the buttons are disabled, there's indications that, hey, hold on, this isn't gonna quite work yet to the user, and then you make things, you enable those things on the first render, full render. And the 4th lesson is really, and I think this is in some ways a recurring theme. It was a theme in Sunil's talk, and in some ways I want to say that this talk is more like a prequel to Sunil's talk. We need better tooling to deal with this. We need to help people fall into the pit of success, and I hope some people are excited by these ideas and start working on it. There are some great projects that are starting to work on these things, but I don't feel like there isn't a Create React app for server rendering that really includes streaming in the way that I would like to see. I want to point at a couple projects. One I've worked on some. It's from my old company, React Server. React Server does some of this stuff. It sends down root elements separately. It allows you to say, hey, render these ones first on the server, then start sending down the JavaScript so you can sort of tweak that and tune it. It doesn't do all the pieces perfectly, and it doesn't split up CSS, for example, but it does a lot of these things, and I encourage you to check it out. As Sunil was talking about React, I think that has a lot of great ideas and a lot of overlap with the stuff I've been talking about. And speaking of JavaScript fatigue, I woke up to an email that there was a pull request from Sebastian Markbridge on the React team this morning. It's like only in the React community can you be working on a talk for 3 weeks, and then there's a pull request in the morning of your talk, and you have to add slides. Because things change a little fast here, right? Sebastian just merged a server renderer in React 16 that actually supports streaming as a renderer. So it actually, rather than rendering to a string, it should be able to, I think it hasn't been tested yet, but it should be able to render to a node stream. So you don't actually have to block while streaming, which is actually, or while rendering on the server side, which is a really exciting development. I wrote my own library in user space and didn't maintain it well. And I've been trying to get that into Core React for a long time, and I'm so excited about that. So there's lots of cool things going on, I think, in streaming in React, and I think it's the next step for server rendering, and I really hope that this excites you, and that some of you go work and help people fall into a pit of a success where the default for React sites is like, oh yeah, React sites, they're made with that and they just render fast. So these are some of the image credits, and thank you all, and I'd love to talk to any of you. Thanks so much.